A very good morning to all my students. Children, I'm quite happy with the way you wrote your chemistry exam. I'm really satisfied. Hope you are understanding all my lessons well. And as you know that we have left two main topics actually, two small topics from the lesson acids, bases and salts. So as you can see, one of that topic is water of crystallization. This week we will go ahead with the water of crystallization. So you can see that when a salt crystallizes, it takes in its structure a few molecules of water also along with it. I gave a small introduction about the water of crystallization when I discussed about the washing soda. Do you remember, children? So what is the formula of washing soda? It is Na2CO3.10H2O. So what is this 10H2O? During its formation, it takes some water molecules along in its structure. So 10 water molecules also bind and they are a part of the formula unit formula of that compound. So this is called as washing soda. So these 10 molecules of water are nothing but called as water of crystallization. If I write only Na2CO3, then it is simply called as sodium carbonate. When I write .10H2O, then it is nothing but washing soda. So that is, we will be learning more about water of crystallization today. You can see that I have taken a salt, copper sulfate. It's called as blue vitriol, is it not? So it is a blue colored crystalline solid. When you heat that blue colored copper sulfate, it changes its color, it decolorizes. When you heat it, it decolorizes. So why is it getting decolorized? Because it is losing the bound water molecules which are present in the copper sulfate molecule. So here you can see that when you heat, all the water of crystallization is getting evaporated. It is getting lost from the structure, from the formula, and what you get is nothing but called as anhydrous copper sulfate, which called as anhydrous copper sulfate. Okay. So this salt with no water molecule is called as anhydrous salt. What is it called, children? Anhydrous salt. So here what is happening when you are heating? Actually the water of crystallization is lost. So these are the various examples of such compounds which contain water of crystallization. So what is the other name? How can we name this compound? We can call this as sodium carbonate decahydrate. I told you, decahydrate means it contains 10 molecules of water. Copper sulfate pentahydrate, that means it contains 5 molecules of water. Iron sulfate heptahydrate, that means it contains 7 molecules of water. Calcium sulfate, what is that? Dihydrate, that means it contains 2 molecules of water. So this particular compound is called as gypsum, children. We will be learning about more of this salt now. What is it? It is called as gypsum. It's a hard solid actually which is nothing but calcium sulfate containing 2 molecules of water. Okay. Now for this anhydrous salt, if you add few drops of water, now it has become white now. Previously it was blue in color. Now when you heat the mixture, heat the salt, then what happens? I told you that it gets decolorized. It becomes white or pale. Then again, after if you remove it from the heat and add few drops of water, it gets back its original color. Why is this happening? Because it is getting again its water of crystallization. If you supply more amount of water, more than 10 molecules of water also, in spite of this, the molecule takes only 10 molecules of water. The compound takes only 10 molecules of water, not more than that. So that is not specific. The number of water molecules that a substance has, that a crystal has, is constant. It is specific for a given substance. So here it is only 10 water molecules that it takes. So it gets back its original color. Okay. Let's learn more about gypsum now. Okay, children? Okay, let's learn about gypsum, children. So gypsum is a hard setting, it's a hard solid actually. Which is nothing but calcium sulfate dihydrate. Okay, so this upon heating, if you heat this at a temperature of 373 Kelvin, then it loses 1.5 molecules of water, and the product that is formed is called as plaster of Paris. Actually, gypsum is found more near the places of Paris actually. So there are more reserves of gypsum. So from there, the production of plaster, nothing but calcium sulfate hemihydrate is formed more. The preparation, owing to the abundant preparation, it's called as plaster of Paris. There is no specific reason behind calling it as plaster of Paris, only for the fact that it is prepared more in abundance in places of near Paris, because there you find more amount of gypsum. So here what is happening to gypsum? When you are heating it to a temperature of 373 Kelvin, it loses its water of crystallization. So regulated heating, it is at a temperature of 373 Kelvin, it loses 1.5 molecules of water. Now how many molecules of water will be left here? Half molecule of water will be left, that is nothing but plaster of Paris. One thing you have to understand here is that we don't have certain thing like half a molecule. We don't have half a molecule of any substance. What it means actually is this one, I can write like this: 2 molecules of calcium sulfate are taken. That means how many molecules of water will it have? 4 molecules of water, right? So upon heating, 3 molecules of water will be lost. Now how many will be left? 1 molecule will be left. That 1 molecule of water will be, actually 2 molecules of calcium sulfate will be bound by 1 molecule of water. So in order to show this, we can't show like this. So simply they are showing it like this. Each one will have half a molecule of water. It means that, children, actually 2 molecules of calcium sulfate will be held with 1 molecule of water. 1 molecule of water will be actually holding 2 molecules of calcium sulfate. So that is what we are going to show here. Out of the 4 molecules, 3 molecules are gone. 1 molecule is left. So half we are showing here in the reaction. 2 molecules, out of that 1.5 is gone, and then what is left is nothing but half molecule. Hope you understood it. 4 molecules, 3 molecules will be lost and 1 will be remaining. We are showing half a reaction because we are taking 1 molecule over here. It's difficult to represent it actually. That's why we are representing it like this. Okay, children. So what is the use of plaster of Paris? Now you might have, this is nothing but POP, what we call, isn't it, children? What is POP? Plaster of Paris. We use it usually, the orthopedics actually, they use it for setting the bone, isn't it? To place the bone in the right position. We have that bandage, isn't it? The POP bandage, as we can say. It sets hard. Initially it will be like white powder. They mix it in water and then it becomes like a paste now. That paste is actually put around the broken or fractured bone to place that in order, in the right position. And then when it dries, it sets, isn't it? So it sets again to the hard mass. It sets again. What happens then? It is mixed with water again. So when it is mixed with water, what happens, children? It takes the water of crystallization and becomes gypsum again, which is nothing but the hard substance. So that is nothing but, plaster of Paris. They use not just for this, supporting the fractured bone, but also they use it for making decorative items, toys, or sometimes it is also used for making the surface very smooth before painting also. It has got its own applications in day-to-day life. So what is plaster of Paris? It is nothing but calcium sulfate hemihydrate. Once it mixes it with water, it forms gypsum again and it sets to a hard mass, which is nothing but gypsum. Okay, children? So that's all for today, and in my next class I'll be talking about one more salt, which is nothing but bleaching powder. Okay, that will complete our lesson. Thank you.